Math 1108, Test 3 Review Sheet, Section 8.3, Simplifying Rational Exponents. In Part A, we want to simplify 64 raised to the exponent 3 over 2. So the denominator of the exponent is the index of the equivalent radical. So what I suggest is, using one of the definitions, rewrite this as 64 to the 1/2 raised to the exponent 3. From section 5.2 that was covered some time ago, we learned the properties of exponents. So we're just applying one of those properties. If you remember, in a case like this, if you have 64 to the 1/2, and if that's raised to the exponent 3, then that's equivalent to multiplying the exponents to get 64 to the 3/2. The reason that we want to write it this way is because on the inside of the parentheses, 64 to the 1/2 is just the square root of 64, or the principal square root of 64, which is 8. And then we raise that to the third power. So 8 to the third power is just 512. 8 times 8 times 8. Okay, in the next example, this time we have a negative number, negative 64 inside parentheses, and the exponent is 2/3. We'll do the same sort of thing as in the previous example. We'll rewrite this as the number negative 64 to the 1/3, and then raise that to the exponent 2. And then once again, if you recall the properties of exponents, if you multiply the exponent 2 times the exponent 1/3, 2 times 1/3 is 2/3. But if we start on the inside and work out, we recall that the cubed root of negative 64 is negative 4, because the number negative 4 to the third power is negative 64. So we can simplify the number negative 64 to the 1/3 to negative 4, and then we raise that to the outer exponent 2. The number negative 4 raised to the second power is positive 16, because negative 4 times negative 4 is 16. Okay, in the next example, we're multiplying two terms that have the same base, 6, and so one of the properties of exponents says that we can write the base and add the exponents. So 6 to the 5/2 plus 1/2. And we can easily add 5/2 and 1/2, so we can write this as 6 to the 6/2, but 6/2 is 3, so this is 6 to the 3rd. And 6 to the 3rd is just 6 times 6 times 6, which is 216. Okay, the next example, in the numerator we have 32 raised to the exponent 3/5, and in the denominator we have 16 raised to the exponent 3/2. Well, there's more than one way to go about it, but I think the easiest way is to rewrite the exponent, or the numerator, 32 to the 3/5, as 32 to the 1/5 raised to the third power. And you can verify that this is correct because 3 times 1/5 is 3/5. And we'll do a similar type of thing in the denominator. 16 to the 3/2 is equivalent to 16 to the 1/2 to the third. And then in the numerator, remember that 32 to the 1/5 is just 2. 32 is a perfect fifth power. 32 to the 1/5 is 2. So we have 2 to the third power in the numerator. And in the denominator, 16 to the 1/2, that's just the square root of 16. And the square root of 16 is 4. And so we end up with 4 to the third in the denominator. Then simplify 2 to the third. That's 2 times 2 times 2, which is 8. And then 4 to the third is 4 times 4 times 4, which is 64. And finally, the fraction 8 over 64 simplifies to 1 over 8, 1/8. Okay, and the final two examples in this section, we will convert the radicals to rational exponent form. On this radical, the index of the radical is 5. So that means that we put what's inside the radical in parentheses, 5x to the 4th, y to the 3rd, and then we give it the exponent 1/5. In the exponent, the denominator of the exponent has to be the same number as the index of the radical. Well, in one sense, this is a perfectly fine answer because it is in rational exponent form, but we can take it one step further. But in doing so, keep in mind that 5 is understood to have an exponent of 1, even though we don't normally write 5 to the first. But in this case, it might be useful to remember that, because when we apply one of the properties of exponents, we're going to multiply the outer exponent 1/5 times each of those exponents, and we can write this as 5 to the 1/5 power times x to the 4/5, because 1/5 times 4 is 4/5, and then times y to the 3/5, because 1/5 times 3 is 3/5. Okay, in the next part, we'll also convert the radical to rational exponent form. This time, the index of the radical is positive 3. So we put in parentheses what's inside the radical, 27x to the second y, and then the outer exponent is 1/3. Okay, so this is equivalent to the radical form, it's just now in rational exponent form. Okay, so we will take it one or two steps further. Think of 27 as 27 to the first. Think of y as y to the first. And then when we apply the outer exponent, we're going to multiply the outer exponent 1/3 times each of those three exponents. And we get 27 to the 1/3 times x to the 2/3 times y to the 1/3. Well, we can simplify a little bit further, because 27 to the 1/3 simplifies to 3. 27 is a perfect cube, and so 27 to the 1/3 is just 3, and so our answer becomes 3 times x to the 2/3 times y to the 1/3. In the previous video on, if I can find it, oh yeah, in the previous video on sections 8.1 and 8.2, I didn't quite finish this problem, so I have time, so I will reorient what we were doing in that one. When we started out with the cubed root of a quotient, we observed that the quotient, or the rational expression inside the cubed root, cannot be written in lower terms. So we applied the quotient property of radicals, and we wrote the cubed root of 16m to the 27th in the numerator, and the cubed root of 125 n to the 60th in the denominator. If we focus on the denominator, 125 is a perfect cube, and the cubed root of 125 is 5. N to the 60th is also a perfect cube, because 60 is a multiple of 3, And so the cubed root of n to the 60th is n to the 20th, because 60 divided by 3 is 20. In the numerator, I'll simplify this in a couple of steps. The largest factor of 16 that is a perfect cube is 8. M to the 27th is a perfect cube because 27 is a multiple of 3. So we can rewrite this numerator as the cubed root of 8 m to the 27th, and then multiplied by 2. And then the denominator has already been simplified to 5n to the 20th. And then the final step, the cubed root of 8 is 2. The cubed root of m to the 27th is m to the 9th, because 27 divided by 3 is 9. And we must multiply that by the cubed root of 2. And then the denominator is 5n to the 20th.